I am not Gonzalo Rada, and what I'm going to be presenting today is a presentation he gave to the LTPP Oversight Committee last week. He and I have been working together on this project, and it's to develop the plans and specifications for a long-term pavement performance program in the area of pavement preservation. Gonzalo is the PI. I used to work for AMAC. When I moved from Oregon State to California, I set up an office there, and after retiring from Oregon State, and so I've had a history in working with Gonzalo and others. What I'd like to talk about is the background of this program, an overview of the experimental approach that we're taking, some key considerations, the experimental designs that are being developed and the project layouts, and then how we're going to begin to get the word out. Now, in terms of the background, LTPP has a mission of trying to increase pavement life using different technologies. Of course, in the original SHARP program, they looked at asphalt and concrete. The SPS-10 project is now looking at warm mix asphalt mixes, and what we're proposing is a program for both asphalt preservation and concrete preservation, and try to understand how pavements behave and why they work as they do. Our project objective is to develop experiments for the LTP program to provide both short and long-term performance data on pavements relative to preservation. There's been a lot of anecdotal evidence that preservation works, and certainly Montana DOT has shown good information on joint sealing and that it works for them. But a lot of other information, a lot of other treatments, we're not sure exactly how long they work and what sort of performance jumps we get and the life extensions we get with the associated preservation treatment. So this experiment is to try to document the impacts of preservation and to enable development and implementation of some of the important tools and products. Now, this is a two-phase project. We're just completing or just have got approval of phase one, which discusses the development of the experiment design and the materials and testing, sampling and testing plan. I was in charge of the materials sampling and testing plan. Gonzalo was in charge of the development of the experiment design. Phase two, which is going to start now and should be close to complete by the national conference, Larry, will include some really critical elements. What are we going to monitor on each of these treatments? For concrete or asphalt, what sorts of performance indicators do we need to look at? And as all of you have talked about earlier, probably the most important aspect of this whole program is developing construction guides or requirements for pavement preservation treatments. We can design these treatments, but if we don't have a good contractor to place the treatments in a quality manner, the treatments will not perform necessarily as expected. The other thing, we'll be collecting other data needs like traffic, climate, things of this sort, and then there is a marketing and technical support. Now, what we've got to do in this second phase is to go out and help sell the program to the various states. This is actually some of the first marketing efforts that we're doing as a part of this overall effort to at least make you aware of the program. It's not going to be constructed until probably 2017, so we're a ways away. So we are developing the plan so that we can make sure we get a good experiment that can be implemented very easily. We have an oversight group, and some of the members of that oversight group I wish were not here. Larry Schofield and Jim Moulthrop. But David Lohr is a very supportive guy, but Anita Bush is on our group, Colin Franco of Rhode Island, Morgan Kessler, who is kind of the co-chair of the PP Pavement Preservation Expert Task Group, Magni Mihail of Texas DOT, who is also a co-chair of the PP Expert Task Group, Moulthrop and Schofield, who are the devils in the group, and then Roger Smith, who was responsible for the original SPS 3 and 4 experiments that were developed back in the 90s. And we wanted to learn from his experiment and make sure that we did not repeat any bad lessons. We wanted to learn from the good lessons. And then Ben Worrell of Minroad, who is participating with NCAT on the NCAT Minroad project. So we've got people that are involved in the national effort, people involved in asphalt, concrete, and the like. Now, the Phase I activities, we had a kickoff webinar with our ETG in January. We had a face-to-face meeting with them in April, another webinar to go over some of the final plans in July, and then we finally had the last webinar with them in September to go over some of the revised plans on the experiment in particular. The experiment design drives the materials and sampling and testing program because the treatments that are used have different materials and sampling testing requirements. So the overview of the experiment, again, we have two experiments. SPS-11, as Larry talked about, that's asphalt, and SPS-12 is for concrete. They're consistent with other LTPP experiments in that a lot of the data collection stuff is similar and so on. The experimental approach was to segregate treatment types and pavement project locations into discrete groups and apply the same preservation treatment at different times on the pavement structure. Now, in the previous experiment, SPS 3 and 4, they applied multiple treatments. NCAT and Minroad are applying multiple treatments, but the one question that a lot of people cannot answer is the optimum timing of the treatment. Now, Scott discussed that a little bit earlier with some of the work that he's done on slurries in RTC, but we want to put the same treatment down at different times to see if we can document the optimum timing of the treatment. So NCAT and Minroad are looking at multiple treatments. We're looking at basically a single treatment that can be placed at different times, but we have the opportunity to place supplemental test sections at the same location to evaluate different products. That's not precluded from this experiment design. That's, as Larry Schofield aptly termed, the Cadillac design, one where we can look at different treatments and look at optimal timing for different treatments. We think the studies complement one another, and that's why we've got Ben and Jim and Larry on the ETG so that they can make sure that we complement other studies. There's another study that's just starting on concrete pavement preservation. It's a pooled fund study managed by Washington State DOT. Jeff Oldmeyer is the PI, and they'll be looking at a variety of preservation treatments for concrete. So we've got the opportunity with these three significant studies to work together and get the biggest return for our dollar. So that's what we're trying to do. An example SPS-11 project might include 6 test sections. 1 control with no overlay, this would be for a thin hot mix overlay, say, and 5 treatment sections applied at different times maybe 2, 4, 8 years, or maybe a longer time depending on the deterioration rate, or a shorter time if the pavement is deteriorating faster. These numbers are not fixed in stone, as you'll see later. Each pavement has a unique distress propagation rate. Some are going to crack more quickly than others, and this is why we're looking at this one treatment required per project. It'll reduce the number of test sections required. It'll enhance implementation because the cost of the state agencies, the states will have to bear the construction costs, but the Federal Highway Administration will take care of all the monitoring costs. So it's in the best interest of the states, in my opinion, to do more sections and add supplemental sections to evaluate the products that you might want to look at. And therefore, meaningful results are not reliant on all the other project slides like they were in the SPS 3 and 4 studies, which was a factorial design which required using data from different climates and different traffic areas to get meaningful results. Now, there may be some shortcomings, and one of them is materials. In the SPS 3 and 4 studies done in the 90s, in the western region, you used one contractor, one aggregate, and one emulsion. Isn't that correct? Old timer over there, Larry? Larry was on that tour. That's when he was on the dark side. And that's going to be a problem in this study because we may not be able to use the same contractor. Therefore, what do we have to do? We've got to make sure we've got good construction guides to make sure that a low bid contractor is not going to cheapen the job. Not that there's anyone that would do that, but we want to make sure that that doesn't happen. And so we'll have just-in-time training. We'll have all sorts of things within those construction guides to ensure the products that are placed properly and to eliminate any of the problems with workmanship. We were originally a little concerned as to the reception of the approach, but the reaction that has been gleaned from audiences where these presentations have been given has been very positive to look at the timing effect. But we want to make sure that we stress that there are other opportunities, such as the supplemental test sections. Now, some of the key considerations are what are the preservation treatments that we're going to look at, the type and age of the pavements. Again, preservation treatments should be placed on good or fair pavements, so we want to make sure that happens. We'll have up to 20 years to monitor data, but we're hoping to get short-term data as well as long-term data out of this project. We want to make sure we monitor the climate and the traffic and make sure that we do have some replicate or repeat sections in the study. And then finally, the supplemental sections. We want to make sure that the states buy into the idea that they can add sections to study other treatments. Now, we're involved in an NCHRP project right now on performance measures and did a survey of all of the states, I think Montana and Idaho and all the states that are represented here. And it came back that the three most important treatments in the asphalt area were thin hot mix overlays, chip seals, and microsurfacings. That's what the people wanted. Now, crack sealing is important, but that was not one of the top four, even though Larry and Jim would like to see it included. That doesn't mean that the agencies cannot include it in this study to look at the effectiveness of joint sealing, but these other treatments were not as highly ranked, and we thought it would be important to focus on the most important treatments initially as a part of the core treatments, and then add additional treatments as needed as a part of the supplemental sections. The same was true for SPS 12. Diamond grinding and Dalbar retrofit were right at the top, as was joint sealants. Joint penetrating sealers weren't even on the radar, or concrete hardeners. Partial depth patching, full depth patching were, but we ended up through a series of meetings with the ETG and others and came up with, for concrete pavements, looking at diamond grinding and Dalbar retrofit, joint sealants and joint penetration sealing. Now the diamond grinding could be independent, like you do, David, on some of your sections, or it could be done in combination with the Dalbar retrofit. The pavement types, we originally thought we might look at original asphalt pavements, but how many original asphalt pavements are out there? Most of them are probably asphalt overlays over existing asphalt pavements, so we're going to use that as the SPS-11 existing pavements, and then for the SPS-12s, a few states use CRCP, very few states use reinforced concrete pavements, so most of the concrete pavements on which we'll place the treatments will be the jointed. As far as pavement age, now these aren't set in stone. There's going to be flexibility built into some of these numbers, but we want to look at placing asphalt treatments maybe starting less than 4 years. It all depends on the condition of the pavement, and the concrete pavements anywhere from 4 to 10 years. We want to make sure we get it just before it starts deteriorating, and then we'll apply the treatments at time 0, which might be 4 years, time 0, which might be 10 years, and then go out into the future to evaluate the optimum timing of the treatments. Climate, we'll use the same LTPP climate data and thresholds, and we'll probably rely on this MIRA data for temperature, which is what LTPP is using at this point in time. It's apparently the best database. I haven't used it yet, but my colleagues say it's a very good database for climate and temperature. Traffic volumes for SPS-11 experiment, we'll probably look at both volumes and easels depending on the importance of the pavement. On low volume roads it's probably volume only, but on higher volume roads it could be a combination of volume and easels to pick out our test sections, because we want test sections in all of the climate zones, and we want test sections that are in different traffic levels. For concrete pavements, it'll be easels only, because concrete pavements are thicker, and it'll probably be easels only, and the approach that we're looking at is the same as what is used in the warm mix experiment, which has just begun. They're already building projects, and so in the warm mix projects, the differentiator on easels is 500,000 easels per year. Less than that, it's low. Greater than that, it's high. That's what we're looking at right now. And this kind of summarizes the differentiation between low and high traffic based on both easels and vehicles per day. Now, we will have replicates. I know Gonzalo always depends on funding, and of course everyone has limited funding, but we'll have replicates, and it'll be a minimum of 2 per cell, but it may increase depending on the level of funding that we can find. But we're going to have to fight for funding from the feds, and you'll probably have to get funding from the states to build these sections, but we'll have to fight for funding from the feds to get the monitoring. But the feds are all supportive right now, and a lot of the states are very interested in doing this study. Now again, there will be repeat sections, and there'll be the supplemental sections, which for chip seals, what would be a good supplemental section for a chip seal? A cape seal? A scrub seal? You know, a variety of, what? Crack sealing could be a good, yeah, that would be good. You got it in, didn't you? For microsurfacings, what would be a good supplemental section? You could put slurry seals down, you could put cape seals down again, you could put a variety of treatments. So you've got these options to put down different treatments. Now we do have crack sealing or joint sealing for concrete pavements, guys. Experimental designs and project layouts. Here's just the proposed matrix for the SPS-11. Again, we have 3 treatments that are the core treatments. We'll have wet and dry, freeze, no freeze, and traffic will be high and low. So those are the combination of projects that we're looking at throughout the United States. Now in Montana, Mary, the sections, your sections could be dry freeze. You could also have wet freeze. I don't know, maybe you'd only be in low traffic, but maybe you'd have high traffic too. I don't know. But this would be the sorts of sampling templates that we would use to get the projects, and each state would, each of the regional LTPP contractors would work with the states to select these projects. A typical SPS-11 layout. This one shows, let me see if I can, this one says treatment test section 1, 0 years. This is the control. So this one is with a treatment, let's say it's a thin hot mix overlay placed in 0 years. This one is going to be placed in 2 years. This one is in 4 years. This one's in 6 years. And this one is in 8 years. So we'd have a variety of times that we could place these treatments. Now, the spacing of the treatments could increase if the deterioration rates are not very fast. And that's what this shows, 0 to 8 years from inclusion. It could be accelerated or decelerated depending on how quickly the pavement remains stable. Now we are going to test all of these pavements using FWD and GPR, and that won't be part of the state's requirements. All of the sampling and testing stuff is going to be funded by a lot of that's going to be funded by the Federal Highway Administration. A sample template for SPS 12, we have the 3 treatments: diamond grinding and Dalbar retrofit, joint sealants, and joint penetrating sealers. Now, how many of you have used or are familiar with the joint penetrating sealers? None of you. See, Larry, I told you no one would know. Joint penetrating sealers are used by about 20-some mid-continent states. What happens is the de-icing chemicals get into the joint and they start deterioration of the joint and cause a fairly significant failure. I wish I had a picture of it, but I don't. But it causes a failure around the joint. And so by using penetrating sealers, these are silenes or other sorts of materials, you can waterproof the joint and prevent the de-icing chemicals from getting into the joint and causing the deterioration of the pavement. The diamond grinding and Dalbar retrofit, again, we have a control section. We would diamond grind in 0 years. We would diamond grind and Dalbar retrofit in 0 years. Then we would diamond grind and Dalbar retrofit in 5 years, diamond grind only in 5 years, and I think diamond grind only in 10 years, and diamond grind and Dalbar retrofit in 10 years. So we would evaluate the effectiveness of diamond grinding only and diamond grind with Dalbar retrofit. A lot of these concrete pavements probably don't need Dalbar retrofits. They might, diamond grinding might be more than adequate, and that's one of the reasons we have an expert like Larry on the panel to help us assist in laying out these experiments. Joint sealant. Now this one, will be a cap and replace sealant. So we've got controls with no sealant, and then we have a control with sealant. And then we have, this will be a sealant maintained, and this will be a sealant that is kept as is. So in this case, we have three controls, one with no sealant, one with a sealant kept as is, and another one with a sealant that will be maintained. And as you can see, here's the 5-year, this is a cap sealant replaced at 5 years. This is replace the sealant at year 5 and replace it every 5 years. And then this is a cap sealant at 10 years and then replace at 10-year intervals. And this is a replace sealant at year 10 and replace at 10-year intervals. So we're looking at the effectiveness of no seal. There's a group out there that's called seal, no seal. We're going to look at no seal, seal, seal maintained, and where you replace the seals periodically to see how well those will perform. And I think, again, Larry's to be commended for persisting in getting this portion of the study in the program. I don't mean to be picking on him, but someone has to. Penetrating sealers, again, silenes or siloxanes, and again, we'll have three controls, and then we'll put sealers down at 5 years or 10-year intervals, and to look at the effectiveness of these on the performance of the joints in areas where there are considerable problems with degradation of the joints. So the typical test section will be 500 feet long. There's going to be buffer areas on either side, so the contractor has enough length to get a uniform section, and then the sampling areas will be at the end of the section. In some cases on the leaf side, and in some cases on the approach side. It depends on the treatment. Getting the word out. Now, so far we've had a lot of internal meetings with our ETG. The first 3 check marks there are ETG. We did meet with LTPP in May in Washington, D.C., and present this approach to them. I presented it at Denver at the Emulsion Task Force meeting in June. And then we had another webinar in July with our internal group. Jack Springer of FHWA presented it to the ASHTO's Subcommittee on Materials in Pittsburgh. We are going to January when that's out of place. LTP preservation ETG. The LTP preservation ETG. I don't know what that one is. I'm sorry, but it's out of place, and I'm not sure what it is. But Gonzalo presented it at the Midwestern Pavement Preservation Partnership. He presented it at the TRB Oversight Committee last week, and then I'm doing it here at Bozeman. It will be presented at TRB in 2016 to the LTPP state coordinators. It will be presented at technical sessions at TRB, Anita Bush's committee, which is on pavement preservation, and Judy Corley-Lay's committee on pavement maintenance at TRB.
It's opposite.
Huh?
Opposite.
Is it opposite? Well, I just wanted to make sure someone was aware of that, so thank you. I don't go to TRB anymore, so and then we're going to, I think it's going to be on the national conference, and we'll probably have someone presented on the Standing Committee on Maintenance next July in Las Vegas. But the whole purpose of this is to get the word out, and by the 2016 conference, we should have the construction guides, the performance monitoring, and we should start going out recruiting projects. So I think between now and next October, we have a lot of work to do to develop these construction guides and performance monitoring guides for each of the treatments. And your input would be certainly helpful, but we do rely on our ETG heavily, and we certainly are not afraid to share this information because we think this is going to be a very important program. Now, we're in the planning phases right now. We are going to develop construction guides, performance monitoring guides, and then we're going to work with FHWA to go out and market and recruit projects as a part of this project. I know the construction guides and the performance monitoring guides have to be done next summer, but we'll start recruiting after that. So with that, I'll take any questions unless I've used all the time up. Well, thank you very much.
Thanks, Terry.